When you look up at the moon tonight, what do you see? I mean, if you're like most people, you see this familiar, majestic, but, well, ultimately a pretty passive object.
Right. Earth's silent.
Exactly. The dusty, well-explored rock that's been hanging out for, what, 4.5 billion years?
Yeah.
And we figured, we've got it all figured out.
And that perception is precisely the biggest misconception in modern.
Oh, really?
Absolutely. Because almost everything we thought we knew about the moon, its thermal history, its timeline, and crucially, its resourcial, it was all based on a massive information bias.
A bias? You mean a bias from the Apollo missions?
A bias derived almost entirely from a few hundred pounds of lunar rocks collected 50 years ago. And here's the kicker.
Yeah.
Every single one of those samples came from a small patch of real estate on the hemisphere that constantly faces Earth. It was an inherently incomplete picture.
So we were only looking at one side of the coin.
We're looking at one part of one side of the coin. That version of the moon, the cold, dead, predictable, it's being completely overwritten.
Overwritten how?
We're finding a moon that was volcanically active much, much longer than we ever theorized. A moon that is fundamentally two different worlds merged into one.
Two different worlds.
And a moon that just might, hold the key to clean energy for Earth.
And the surprising truth is that the mission responsible for this seismic shift in lunar science, the project that's quietly generating all this profound new data, it's not the one you hear about every day on this.
No, it isn't.
We're talking about China's methodical, long-term change program.
They executed these missions with extreme precision and a very deliberate, focusing on regions that were completely untouched.
Right.
And the data they're returning, from strange new minerals and unexpected water deposits to unique samples of the moon's interior, it's challenging the core theory planet.
Okay, let's unpack this for you, because the stakes here are genuinely massive. I mean, this goes way beyond just astronomical curiosity. The discoveries linked to these missions, specifically the evidence of widespread water and high concentrations of helium-3, they're potentially tied to solving humanity's biggest looming problems.
Big problems like clean, sustainable energy and, the establishment of future off-world habitats.
So our mission today is a deep dive into this systematic project.
We're going to analyze the deliberate strategy behind China's lunar buildup, what surprising geological truths they revealed by becoming the first to explore the moon's hidden far side.
And why the resources they are identifying could fundamentally redefine the geopolitical and energy landscape of the 21st century. When we talk about space exploration historically, it's always about the space race, isn't it? This dramatic, high-stakes, two-man competition.
The U.S. and the Soviet Union, yeah. It was all defined by this grand televised spectacle, flags, speed records.
The thrill of the firsts.
It was defined by being fast. First satellite, first human, first lunar landing. But after the dust of the Apollo program settled in the early 70s, the focus, it shifted.
It did. The West saw huge budget cuts, turned its attention to the space shuttle program, and then later, it was all about Mars.
Mars. The moon, scientifically it became quiet.
And this is the moment in the timeline where China starts in.
They essentially pick up the abandoned baton.
Right, but they didn't jump in looking for the spotlight. Their approach was completely different.
Completely. It was systematic, incremental, and highly strategic. They weren't focused on grand gestures or flashy live streams. They focused on clean, autonomous engineering designed for the very long term. It's not about beating a rival to a finish line.
So what is it about?
It's about establishing permanent, sustainable capability. The Chain program has been an exercise in strategic planning, essentially turning the moon into a decades-long science and engineering.
Let's start with that sequential strategy, because the early steps were all about proving fundamental ability and just gathering really high-quality data.
Exactly. They started laying the groundwork with Change-1 back in 2007. This was the first warm-up.
Just an orbiter,
yeah. Mapping the surface. But the goal wasn't just pretty pictures. It was to gather high-resolution imagery and, crucially, spectral data.
What does that mean, spectral data?
It tells you what the lunar soil is made of, its composition, its distribution. And this kind of detailed knowledge is absolutely necessary if you want to select safe, resource-rich landing sites.
And then Change-2 followed up pretty quickly, right?
It did, refining that data. This calculated, precise approach meant they weren't rushing. They were building a complete proprietary data set about the moon's surface, the kind of detailed preparation that significantly risks the much more ambitious steps.
And that first major technical statement came in 2013 with Change-3.
That was a successful soft landing on the near side of the moon, and they deployed the U-2 rover.
China's first rover.
It was the quiet proof that they could reliably put complex hardware down, control it remotely, and execute science operations on the surface. They didn't need a huge global countdown. The scientific delivery was the statement itself.
But the real game changer, I mean, the moment the script completely flipped was their successful conquest of the far side in 2019.
Oh, absolutely. That was truly historic, something that required a level of strategic forethought few other nations were willing to invest.
And the far side is so often misunderstood. People call it the dark side.
Which is wrong, yeah. Gets just as much sunlight as the near side. The challenge isn't darkness, the challenge is communication.
Because the moon itself is in the way.
Exactly. The moon is tidally locked with Earth, so the far side is perpetually blocked by the moon's bulk. Direct radio communication just impossible. A lander on the far side is completely deaf and blind to mission control.
So how did they solve this seemingly insurmountable problem?
Well, it required looking beyond the moon itself and placing a massive piece of infrastructure in deep space months before the landing attempt.
And that was the Quequio relay satellite.
The Quequio. They launched it in advance and positioned it at the Earth-Moon L2 Lagrange point, a gravitationally stable spot well beyond.
So think of it like placing a high-tech mirror way out in space.
That's a great analogy. It's a mirror about 400,000 kilometers away that can see both Earth and the far side simultaneously.
And that satellite just bounced signals back and forth.
It enabled mission control to guide the Change 4 lander and the U-22 rover as they touched down inside the mysterious von Karman crater. This wasn't just a landing, it was a demonstration that they had solved the problem of long-term remote operations anywhere on the moon.
And that systematic capability building continued, right? They moved on to the next big goal, resource exploitation and robotic capability.
Autonomous sample. This is where the term future-proofing technology becomes profoundly relevant.
Change 5. Launched in 2020. This was the first mission in over 40 years to bring physical lunar samples back to Earth.
40 years. But unlike Apollo, which needed human astronauts for every little thing,
Right.
Change 5 performed the entire highly complex sequence, completely robotic.
Let's walk through that sequence because the engineering here is it's staggering.
It has to be flawless. So the vehicle lands autonomously, it selects its sample site, it drills deep into the soil, it scoops surface materials, it securely seals them into a container.
And then the hard part.
And then the really hard part. It launches the ascent vehicle off the moon, performs an automated orbital rendezvous and docking procedure with the orbiter high above, and finally returns the capsule safely to Earth.
All without a human hand touching a single control.
Zero human involvement on site. The complexity of that autonomous orbital rendezvous alone is mind-boggling.
Why is that robotic capability so critical for the future? Why not just send people?
Because future resource extraction and infrastructure construction simply cannot wait for humans. I mean, if you want to mine helium-3 or produce rocket fuel on the moon, you need robots. Robots capable of doing the dirty, repetitive, dangerous work for years on end, requiring minimal or zero human oversight. Change 5 proved that the technology to build an autonomous resource operation exists right now.
And they just kept escalating the difficult. Change 6, which launched in 2024, went back to the far side.
The hardest place to land.
It performed that same difficult autonomous sequence, bringing back the first ever physical samples from that hidden hemisphere.
Think about that. Before Change 6, scientists were relying only on satellite images and remote sensing to understand the far side.
Just pictures.
Now we have pristine geological material from the deep, untouched half of the moon. This entire methodical process, from C1 mapping to C6 sample return, it shows a highly deliberate, integrated plan to achieve technological mastery over the lunar environment before you even think about committing to human presence.
Which brings us to the actual science that these untouched samples are revealing. As we said, our old understanding of the moon was built on this massive near-side bias.
The regions we explored, those dark, flat plains called Maria, were formed by ancient, massive lava flows.
They were just easy landing sites.
They were convenient, but they didn't represent the whole picture. Our models were fundamentally flawed because they were extrapolated from data gathered from only one type of terrain.
And the moment Change 4 landed on the far side.
Inside the von Karman crater, yeah. That's when we began correcting that bias.
That location. It feels like a strategic masterpiece of geological targeting. Why was the von Karman crater, and specifically the South Pole Aitken Basin where it sits, so important?
The SPA Basin is immense, just huge. It's one of the largest and oldest impact zones in the entire solar system, dating back nearly 4 billion years.
4 billion.
And when that massive impactor hit the moon that long ago, it didn't just create a dent, it slammed with enough force to breach the moon's protective outer layer, the crust.
So it's like dropping a gigantic bowling ball onto a thin-shelled egg.
That's a perfect way to put it. The impact was powerful enough to crack through the shell and scatter the yolk, the deep inner material onto
the yolk being the moon's mantle.
Precise. The impact effectively dug deep enough to punch right through the crust, exposing the moon's that rocky layer between the crust and the core. And the U-22 rover, as it was exploring the basin floor, found spectroscopic evidence and eventually physical rock fragments consistent with mantle.
This is a huge discovery. Before Chain of 4, our understanding of the moon's mantle was purely theoretical, right?
Purely based on indirect clues like measuring how seismic waves travel through the body.
So now we have actual rock.
Now, scientists have exposed deep rock with a unique chemistry. For instance, the spectral signatures revealed high concentrations of orthopyroxene, a mineral rich in magnesium and iron.
And that's not typical for the surface.
Not at all. It's chemically consistent with the dense material we'd expect to find in the upper mantle, not in the surface crustal rock. It confirmed that the moon has a distinct layered interior structure, but the rocks themselves proved our old samples were not representative.
Okay, so finding mantle material is one thing, but the timeline of activity, you said that throws the entire textbook out.
It really does. We operated under the assumption that the moon, being relatively small and lacking internal heat, should have cooled off and gone dormant really quickly after it formed.
That was the core assumption of the giant impact.
Right. The scientific expectation was rapid. Small celestial bodies lose heat quickly because they have a high surface area to volume ratio.
Like a hot potato cooling faster than a hot turkey.
Exactly like that. But the evidence from the change missions tells a completely different story. What we're calling the age paradox.
What specifically did the far side samples reveal about this paradox?
The volcanic rock samples they gathered from the far side were significantly younger than predicted. They showed signs of activity as recent as 2.8 billion years ago.
What?
That's billions of years after the moon supposedly formed, which challenges the idea that it went dormant quickly.
And the near side samples from Change E5 complicated things even further, didn't they?
They did. They landed near a young volcanic structure called the Dome, and those return samples were dated to only about 2 billion years old.
Just 2 billion. Put that in context.
That is 1.5 billion years after most of the famous near-side Maria formed. It means the moon stayed hot and molten beneath its surface for far, far longer than any pre-existing thermal model predicted.
So something had to be keeping it warm.
Something was keeping the engine running, and this demands new theories about what internal mechanism, perhaps a higher concentration of heat-generating radioactive elements like thorium deep inside the mantle, kept it going for an extra billion or...
So we have confirmation of deep mantle material, and we have proof that the moon was geologically active far longer than we thought. The third key takeaway, then, is that these discoveries confirm we are looking at a tale of two hemispheres.
Absolutely. The differences are not just cosmetic, they reflect two different evolutionary paths.
The near side we see is dominated by those dark, flat Maria.
Right. The basaltic plains formed from ancient flood volcanism, likely helped by the fact that the side's crust is much thinner.
And the far side.
It is the opposite. It's rough, jagged, heavily cratered with a significant thicker crust. The lava flows that happen there didn't spread out into vast, flat plains. The material is clumpier, thicker, and generally lighter in color.
So why the difference? Why did the lava on the near side flow so easily while the far side stayed so rugged?
The working theory points to Earth's early during the moon's formation, the side facing Earth was subjected to intense tidal heat, causing the crust to thin out dramatically. This thinner crust allowed molten magma from the interior to break through more easily and flow out to form the Maria. The far side, protected from that intense energy, cooled more uniformly, resulting in that thick, rugged crust.
So these are geological fingerprints. They prove the two sides evolved under vastly different conditions. We can't treat the moon as a single uniform object.
The conclusion is inescapable. The change missions forced us to view the moon as two distinct worlds sharing a single body. Until now, our entire scientific understanding was built solely on the easy near-side story. Now, the hidden, older, geologically complex half is finally in the light, and it's challenging everything we thought.
This shift from geological history to resource potential is maybe the most exciting part of this deep dive, because what Change 5 brought back from the Dome, besides those younger rocks, wasn't just dust.
No, it was potential energy for our entire planet.
Let's start with one of the most unexpected discoveries from that 2020 sample return.
The isolation of a brand new microscopic crystal never before observed on Earth or found in any Apollo sample. It was later officially named Change Site Y.
This tiny, unassuming crystal, smaller than a human hair. It sounds like something out of science fiction. Why is it so profoundly important?
Because it acts as a highly efficient, natural storage container for something scientists have designated the holy grail of clean energy.
Helium-3.
Helium-3, H3. It's a non-radioactive isotope of helium. On Earth, it is incredibly rare because our protective magnetic field and atmosphere They just block the solar wind that carries it.
But the moon has no atmosphere, no magnetic field.
No protection, so it has been bombarded and passively accumulating helium-3 for billions of years, locking it into the surface materials.
And Change That Why proves that certain lunar minerals are perfect reservoirs for it.
It validates the decades-old theory that the moon holds substantial quantities of this ice. Now, why do we call it the holy grail of clean energy? This requires a quick detour into fusion.
Let's clarify this for our listeners because there's often confusion between fusion and fission.
Right. Our current nuclear power plants rely on fission, which means splitting heavy atoms like uranium.
And that's powerful, but it produces a lot of nasty waste.
Exactly. Long-lived, dangerous radioactive waste that requires secure, long-term storage, which is a major environmental and political headache.
Fusion, on the other hand, is what happens in the sun, fusing light atoms together.
That's it. Current fusion research often focuses on fusing deuterium and tritium. That works, but it still produces high-energy neutrons that make the reactor vessel radioactive. Helium-3 fusion is dramatically cleaner. When you fuse H3 with deuterium, the primary products are non-radioactive, helium-4, and a proton.
So, no long-lasting radioactive waste.
Not pure, clean, massive energy.
The catch is we don't have a working H3 reactor yet.
Not a commercial one, no. But when that technology matures, the entire economic equation of the moon transforms based on current estimates, just a few tons.
A few tons.
Which is highly concentrated in the lunar regolith, could potentially power the entire United States for...
That's an incredible thought. The moon instantly becomes this floating, immense battery and reservoir of clean energy.
Capable of powering civilization for centuries. That is the true so what of finding this microscopic crystal. But the resource discoveries didn't stop there. Ching 5 also made a discovery about water.
Right.
A discovery that fundamentally changes the feasibility of lunar habitation.
We've long known that lunar water exists, but mostly as ice in those permanently shadowed craters of the poles, right?
Which is difficult and extremely energy-intensive to extract.
So what's new?
The new discovery suggests water might be far more widespread and easily accessible. Chang 5 found evidence of actual water molecules locked inside the crystal structure of another mineral they analyzed called ULM1.
So a hydrated salt.
Exactly. This water wasn't just sitting there like frost, it was chemically bound within the mineral lattice.
So the water isn't just hiding in the most inaccessible, coldest corners.
It means that water, specifically in the form of hydroxyl group, is likely mixed into the surface materials, the regolith, across a much broader area.
Including sunlit regions.
And that is a profound difference. If you can easily extract water from sunlit surface materials using relatively simple heating.
You just scoop up the dirt and cook it.
Basically, yeah. Future lunar bases become dramatically more practical. You don't have to send rovers into treacherous, dark craters.
And water, of course, isn't just for drinking or growing food. It's the ultimate space resource because it's fuel.
Absolutely. This ties us directly back into that idea of a sustainable outpost versus a short. You can use electrolysis, split water into constituent parts. Liquid hydrogen and liquid oxygen.
Rocket propellants.
Incredibly powerful and efficient rocket. So if a base can extract water from the soil, generate fuel, and refuel missions heading further out, say, Mars.
The moon transitions from a destination to a crucial transportation hub.
It becomes an off-world gas. Change's robots didn't just find a few rocks. They validated the existence of a rare fusion and confirmed that usable water might be... They opened the door for living off the land.
When you combine the methodical execution of the Change program with these discoveries, fusion fuel and widespread water, it becomes undeniably clear that China isn't operating out of mere curiosity.
Not at all.
They are executing a definitive multi-stage blueprint for permanence.
Every single strategic choice reinforced. They're mapping terrain, testing deep drilling, proving long-distance communication, analyzing volcanic soil. This is the rehearsal phase for a permanent...
It's a different mindset. Historically, space powers treated the moon as a target for a quick photo op.
China is treating it as a new continent to colonize. And they aren't hiding this intention. They are openly developing the concept for the International Lunar Research, ILRS.
Which is this sprawling base concept.
The official goal, in partnership with countries like Russia, is to establish a fully functional lunar base by the 2030s. But what is critical about this plan is the strategic sequencing.
They're not waiting for humans to arrive to start construction.
Exactly. The ILRS is designed to be fully robotic and autonomous at first. This is the ultimate expression of that future-proofing we talked about.
So robots will handle the initial site prep, construction, equipment management.
And early data collection, years before the first crew sets foot there. Think about the efficiency. Astronauts won't arrive to a desolate construct. They will walk into a partially built habitat where the critical infrastructure power, communications, maybe even oxygen already up and running.
And the upcoming missions, they feed directly into this infrastructure blueprint. Change 7, for example, is way more than just another lander.
Change 7 is aimed squarely at the moon's south pole,
Which is the most strategically vital region.
because it's where the largest reserves of water ice are believed to be, inside those permanently shadowed craters. This mission is a full resource survey task.
And what kind of instrumentation is it packing?
It's an exceptionally complex mission profile. You've got a standard lander and rover, but also a dedicated mini hopper and a drone.
A hopper and a drone.
The mini hopper is designed to jump into and out of those permanently shadowed regions to sample the ice and confirm its concentration and composition.
That seems incredibly difficult. The temperature gradients in those craters are extreme.
They are brutal. A region in the sun can be over 120 degrees Celsius, while inside the shadow it can plummet to below Neneko 240 degrees Celsius.
Some of the coldest places in the solar system.
Absolutely. The hopper needs sophisticated thermal management just to survive those, let alone collect samples. The drone adds another layer, needing to operate in a near vacuum where wings are...
And after C7 identifies the resources, then comes Change E8.
which focuses on the holy grail of space sustainability, in situ resource utilization, or ISR.
Living off the land. This is the key to turning an outpost into a permanent home.
It is. Change E8 is specifically designed to test how to use the moon's own material, the regolith, the lunar soil, to build and sustain the base. They aren't just bringing back samples, they're testing the ability to manufacture on-site.
What specific methods are they testing? More than just making bricks, I assume.
Two main areas are crucial. First is material manufacturing, likely through regolith sintering or 3D printing.
Using solar energy to fuse the dust into blocks.
Right, turning moon dirt into concrete for habitat. Second is the extraction of oxygen from lunar rock. Many minerals in the soil, particularly ilmenite, contain oxygen. C8 will test methods to release that usable oxygen, both for breathing and for fuel oxygen.
When you track this whole sequence mapping, communication, sample return, resource surveying with C7, and then in situ manufacturing with C8, it is not random.
It is a cohesive, systematic, and strategic blueprint designed to establish control and permanence.
Which brings us to the shifting dynamic of space power. NASA's Artemis program is highly ambitious, but it faces constant delay.
Delays, budgetary hurdles, reliance on private partners. China, conversely, is executing a publicly funded, integrated step-by-step plan that guarantees consistent progress.
The shift is profound. The old space race was about speed. Who could get there first?
This new race, catalyzed by the data changes returned, is about something much deeper.
It's about who knows how to stay.
Who knows how to stay, who knows what to bring back, and who can control those newly validated resources. The power of being the first nation to establish that permanent station, to control the infrastructure, and define the rules for resources like Helium-3, it gives you a massive strategic advantage. They're shifting the focus from simply visiting the moon to establishing the first off-world economy.
So let's synthesize this new moon that the change missions have revealed.
Yeah.
We started this deep dive thinking the moon was a static, passive time capsule. What we now know is that it is a dynamic, geologically active body whose history holds fundamental clue to the early solar system and how Earth itself became what it is today.
China systematically rewrote huge parts of lunar science by pushing into untouched, high-value places. The far side, the South Pole Aitken Base, they brought back unique, undeniable
Mantle material proving a layered structure.
volcanic rock, proving the moon stayed geologically active billions of years longer than we predicted.
And crucially, the missions validated the moon's immense resource wealth. We're talking about the microscopic change site Y crystal holding the key fusion fuel, Helium-3.
And the discovery of water molecules locked inside common surface rocks, which validates the concept of a self-sustaining lunar outpost.
An outpost capable of producing its own rocket fuel.
And they didn't just rely on old methods. They future-proofed the entire endeavor with complex, autonomous robotic, demonstrating the capability to build and operate a base remotely before humans even arrive.
It's a blueprint.
A meticulous blueprint that shifts the moon from an object of scientific curiosity to a functional resource depot and launchpad.
We used to look up at the moon to admire the glow or to measure the progress of time. Now, we are starting to look at it again, but this time the focus is entirely on figuring out how far humanity can realistically go.
And what energy source will power us into that future. And that really is the final provocative thought here.
Go on.
The moon is not merely a destination anymore, it is the ultimate floating resource island. If helium-3 fusion becomes a reality within the next few decades, the wealth stored in lunar regolith dwarf all current fossil fuel reserves on Earth.
Wow.
Whoever is first to establish permanent resource extraction, whoever defines the laws of access and begins processing that fusion fuel will not just define the future of space, they could profoundly alter the energy and geopolitics of Earth itself. That quiet race for the ultimate energy dividend. It's already